Okay, so today we're going to talk about solving and graphing rational inequalities. So first of all, I'm going to kind of quickly talk about some rules here. I've already done some problems on this worksheet, but basically the rules are, the first thing you're going to do is you're going to move everything to one side. Okay, so we want to move everything to one side, so if there's stuff on both sides, we want to move everything to one side. Next thing you're going to do is you want to combine all that stuff into one fraction, and then you set all of your x's basically to 0. So you want to find those intercepts, right? Those x-intercepts, so you would set them equal to 0. Then, after you've done that, you solve those, and you put your solutions on a number line. You're going to put all those solutions on a number line, and then the last step is to test your solutions to see which parts are actually part of that inequality and which parts are not. Okay? Which isn't as bad as it sounds. So first of all, let's look at this problem right here. So we do not have everything to one side. So I've got this 6 over x plus 2. I need to move that to the other side. So anytime I want to move any kind of term, and this is all one term, right, because it's all part of one fraction, I can just add or subtract it to each side. So I'm going to minus 6 over x plus 2 to each side. Minus 6 over x plus 2. So that's going to set up x over x plus 2 minus 6 over x plus 2 is now greater than or equal to 0. Well, let's look at this. Well, these, in order to combine fractions, they need to have the same denominator. These do, in fact, have the same denominator. So we're going to combine them. When we combine them, all we're doing is just combining everything on the top. The bottom will always stay the same. You don't do x plus 2 plus or minus x plus 2. The bottom stays the same. You're just combining the tops. So x minus 6. So we'd have x minus 6 over x plus 2, greater than or equal to 0. Now I've got that all condensed into one thing. Basically, this is like when we were graphing the quadratics in the intercept form. These are going to be my x-intercepts, or where it's crossing the x-axis, right? So to figure out where it crosses the x-axis, I set both of these equal to 0. So x minus 6 equals 0, x plus 2 equals 0. Solve those, you'd add 6, subtract 2, you're going to get x is equal to 6 and x is equal to negative 2. These are my solutions. Sorry, you can't see what I'm doing. These are my solutions. So this is where I now make a number line. I'm always going to put the least number first, so negative 2. And then the greater number, which would be 6. I put them on a number line. Then I need to put circles on here, right? Remember, depending on the type of inequality, if it's a regular inequality, you're going to have an open circle. If it's a greater than or equal to, you're going to have a closed circle. However, there is an exception on these problems, because if I ever actually have a 0 in the denominator of a fraction, I would get an error, right? It's not possible. It's undefined. So the intercept that's representing my denominator, which is negative 2, right? That's what I get when I solve x plus 2, is always going to be an open circle, right? Because this is just not possible at that value. So negative 2 would be an open circle, and 6 is a closed circle. Okay, so if it has a greater than or equal to, only the top x values are going to have a closed circle. Anything on the bottom is always going to be open. Okay, then we test. So we're going to test our numbers here by plugging them in. So I want to plug in something that's before negative 2. I want to plug in something between negative 2 and 6, and I want to plug in something at 6 or greater. Okay, so when I plug in something before negative 2, it would be negative 3, right? I'm going to plug negative 3 in here for x. So I'd have negative 3 minus 6, which is negative 9, over negative 3 plus 2, which would be negative 1. Negative 9 divided by negative 1 would be positive 9. Is 9 greater than or equal to 0? Yes. So everything before negative 2 is in fact going to work. Then I do the same thing with the value between negative 2 and 6. Easiest one to plug in there would probably be 0. So 0 minus 6 is negative 6. 0 plus 2 is 2. Negative 6 divided by 2 is negative 3. Negative 3 greater than or equal to 0? Nope. So nothing between negative 2 and 6 is going to work. And then I plug in something at 6 or greater. So if I plug in 7. 7 minus 6 is 1. 7 plus 2 is 9. 1 divided by 9 is 0.1 repeating. So that is, in fact, greater than 6. Or greater than 1. So that would also work. So these are my intervals that work. So then I just have to write my interval notation. Would be negative infinity to negative 2 in parentheses because it's an open circle. Infinities always have a parenthesis. Then I have my union. And then this is a closed circle. So bracket 6 to infinity. Okay. Let's look at another one. Let's look at one where we have a actual quadratic. So this top one is basically already in my intercept form. I just have to, set it equal to 0. So, well, let's do that first so I can figure out what that is. So my top, I have 3x minus 12. If I do 3x minus 12 equals 0, I'd add 12, which would give me 3x is equal to 12, and then divide by 3. X is going to be 4. So one of my solutions is going to be 4. Now to figure out the solutions on the bottom, this is in the quadratic form, so I'm going to use my quadratic formula. So I identify my A, B, C. A is going to be 1, B is going to be negative 4, C is going to be negative 5, and I plug those into my formula. Negative, which my quadratic formula is negative B plus or minus the square root, B squared minus 4AC all over 2A. So when I plug that in, negative B, which is negative 4, negative 4 would be positive 4, plus or minus the square root. Negative 4 squared is 16, minus 4AC, so 4 times 1 times negative 5 would be positive 20, so it would actually be plus 20, and then all over 2 times 1, which is just 2. Okay. So 16 plus 20 is 36. Square root of 36 is 6. So I'm going to have 4 plus 6 all over 2, and I'm going to have 4 minus 6 all over 2. Well, 4 plus 6 is 10. Divided by 2 is going to be 5. So x is going to be equal to 5. Or x is going to be equal to 4 minus 6 is negative 2. Divided by 2 is negative 1. Negative 1. So I have 3 solutions here. I have 4, 5, and negative 1. Okay? So that means on my number line, I'm going to have 3 circles. Least number is negative 1. Next least is 4, and then 5. Now, my solution on the top was 4. I guess it doesn't matter because there's no line underneath of it, so all of these would have to be open circles. But if this has been a closed circle, the 4 would have a closed and the others would be open because these are from the bottom. But since this is a regular inequality, all of these are open circles. And then I've got to test all of these to see if they work. Now this is going to be kind of a pain to test because you've got a big old equation here to actually test here. So I'm going to shortcut here. And I am going to just very, very quickly look at my answer key. Okay. So if you test these, anything less than negative 1 is actually going to be less than 0. So this is going to work. Anything between negative 1 and 4 is going to be greater than 0. And again, I can test that real quick by plugging in 0. 0 would cause all these x's going to go away, which would just leave negative 12 divided by negative 5, which is a positive number. And that would, again, be greater than 0. And this is looking for everything less than 0. Between 4 and 5 does work, and then everything after 5 does not. So my interval notation here would be negative infinity to negative 1 with parentheses, and then I'd have a union, and then I have a parenthesis 4 to 5 would be my next interval that works. And that is what you're doing for quadratic inequality, or not quadratic, rational inequalities. Anything else you want me to go over, Nebuchadnezzar? Okay, that'll do.